If you haven't been living under a rock for the last couple of years, you've probably heard of Bitcoin. Bitcoin, along with other virtual currencies like Bitcoin, Litecoin, and Ethereum, are built on blockchain technology. Blockchain technology is as big as ever in the tech world, as seen in the ever growing popularity of cryptocurrencies. Even tech giants like Facebook have started investing their own cryptocurrencies as the Libra coin releases in 2020. So, what is blockchain? Blockchain is a virtual database that stores and updates information. As its name would suggest, the information is stored in a chain of blocks, where each block contains some information and is linked to the next block. Cryptocurrency uses blockchain to store transactions in a permanent public list. Each transaction is stored as a block in the blockchain. In fact, a blockchain is designed to be immutable, meaning that once a block is written to a blockchain, it cannot change or get deleted. This means that no person can manipulate or tamper with the data, which is what makes blockchain technology so secure. But what makes cryptocurrency so appealing? First, let's explain what a cryptocurrency is. Let's break down the word crypto and currency. Crypto represents the privacy part of cryptocurrency, and currency is a medium of exchange, which is a form of payment like cash and credit cards. However, cryptocurrency differs from the real world currency because it is like a digital currency. Back to the question, what makes cryptocurrency so appealing? Cryptocurrency allows participants to remain anonymous while trying to make a transaction. In general, two people, the sender and receiver, rely on a third party, usually a bank, to make a transaction. The bank requires each party to share information regarding their identity, such as their social security number. However, through cryptocurrency, this is unnecessary. Instead, cryptocurrency uses cryptography, which secures the identity of users and regulates the transactions to prevent any wrongdoings. As a result, this replaces the role of a bank or any third party in the transaction process. This is referred to as decentralized. The transactions are made peer to peer. There's just one problem. How do we make sure that thousands of people can agree on one transaction? Well, that's where consensus algorithms come in. What are consensus algorithms? A consensus algorithm is a process done in order to get a group of people or computers to agree on a single data. In cryptocurrencies, these types of algorithms are necessary to ensure that transactions are legitimate and to prevent users from taking control of the blockchain. There are many different types of consensus algorithms, but let's take a look at the first and most widely used consensus algorithm, the proof of work system.
The proof of work system has been established by cryptocurrencies such as Bitcoin and Ethereum. This system involves miners, nodes, and blocks. In a cryptocurrency, a node is any device part of the network that receives a copy of the past and ongoing transactions. This forms a blockchain, a record of transactions. A so-called miner is a special node. Miners are people that own specialized computer hardware that are designed to help process transactions using the proof of work system. A block in a blockchain is a collection of previous transactions and other information. To help understand how proof of work works, let's refer to a group of students. Each student is using an electronic device. They are all waiting for the next math problem needed to be solved through a public network. On their device, each student has a copy of a permanent list of already solved problems and answers, which is posted on the public network. Once the students identify the math problem, they compete with each other to be the first to solve the math problem. Assumingly, all the students are capable of solving a math problem, but just a difference in timing. Once the first student figures out the answer, the student will share the answer with the other students. Eventually, more and more students have solved the problem as well. These students will confirm whether the first answer is correct, and if it is, they will post the answer to their copy. After a certain number of confirmations, the answer will be deemed correct, and the first student will be rewarded with points that could be used to buy whatever they like on a certain platform. Through this scenario, hopefully you can now picture proof of work more easily as we explain in more technical terms. As previously mentioned, miners are responsible for processing transactions in a blockchain. This group of students are similar to a group of miners. Each miner has a copy of the blockchain as each student has a copy of the already solved problems and answers. The miner uses the solution to form the next block, which contains transaction information. Similarly, the students enable the process of creating a new block by solving the math problem. Both the first student and miner will be rewarded after their peers have confirmed the solution to be correct by posting the solution to their copy. In the end, the student will be rewarded with points and the miner will be rewarded with transaction fees. So, how exactly does proof of work prevent evil users from taking over the network? Simple. After the first miner successfully solves the problem, the other nodes verify that the new block is valid before it is created. Because of this, if an evil user ever tried to create a block that was invalid, all the other nodes in the network would be able to shut down the invalid block from being created. If you have been following along carefully, you will have noticed a couple of flaws in the proof of work system. One issue to consider is the high processing power miners need to use to solve the complicated mathematical puzzle. This leads to high electric bills and eventual environmental problems. In addition, as previously mentioned, a major concern is the security of the network. An example is the 51% attack. If a malicious group is able to attain 51% of the total processing power, they will be able to control whether or not blocks get added to the chain, giving them the ability to prevent new blocks from being added or created. However, getting 51% of the total processing power is hard to do and have not been successful so far.
Next, let us look at proof of stake. In 2011, Sonny King and Scott Nandel began creating a new consensus algorithm, proof of stake, to solve proof of work's energy consumption problem. Instead of doing math calculations to add a block to a blockchain, proof of stake validates a new block depending on how many coins the validator has. So, what does this exactly mean? For example, let's say you want to win a raffle prize. The chances of you being chosen depends on how many tickets you purchase. The more tickets you have a better chance of being chosen and win the prize. This also applies to proof of stake. In proof of stake, the validator is chosen in a pseudo-random way. However, in this system, the more stakes or coins you have, you're more likely to be chosen. Each validator must own a stake in the network. They do this by depositing a certain amount of coins into the system and locking it up in a virtual safe. The more coins you lock up, you have a better chance of being selected. When the validator gets chosen to add the new block onto the blockchain, he or she checks if the transaction is valid. After this, the validator is rewarded by earning the transaction fees that was associated with adding the blocks onto the chain. So, how do you know if the proof of stake system is secure? When you deposit a certain amount of money and lock it away, the system detects if the validator is up to any malicious activity. If it finds any unusual behavior, the validator will lose a part of its share as well as their rights to participate as a validator in the future. In addition to losing a part of their share, the validator will also lose more digital coins than they would gain when trying to commit fraud. As it was previously stated, proof of work requires a large amount of computing power and electricity, due to the fact that the miners need to solve difficult computational puzzles to acquire the new coin. But in the proof of stake algorithm, the chances of a validator being picked is just simply the amount of stake the users put in. Therefore, in the proof of stake algorithm, we do not need as much computing power and electricity to acquire the new coins. 51% attack will be harder to achieve in the proof of stake system. Let's take a look at a hypothetical situation. How would a 51% attack happen? For a 51% attack to occur, a user or a group of users, often referred to as a pool, will need to gain ownership of more than 50% of the cryptocurrency. Thinking about it, why would someone bother to attack the cryptocurrency when they have more than 50% of it? Not to consider the fact that it is really difficult and expensive for someone to take hold of 50% of the cryptocurrency, which is something that has a high volatility index. Especially in the proof of stake algorithm, the validators are being picked randomly, so there is no guarantee that the bad user will be picked to validate the new coin. But if the 51% attack does happen, then that user will be blacklisted and the miners will just automatically move on to the longer eligible blockchain. Even though proof of stake was created to solve the problems proof of work was creating, it still has some downfalls to it. To start with, one downside to the proof of stake is the rich eventually gets richer. Based on the previous analogy given, the more stake a user decides to put in, the bigger chance the user will be selected to validate the new token, and eventually earn the transaction fee. Another disadvantage of the proof of stake algorithm is that the only way you can acquire coins is from someone who already owns them. However, in proof of work, you can acquire the coins yourself by mining them. Even though proof of stake is more of a recent algorithm that is adopted into different cryptocurrency blockchains, it avoids the downsides to the proof of work algorithm to make the validation and transaction process more efficient. There are many differences between these two proofs, even just from the basics of how new coins are being added to the blockchain to how the algorithms react to the evil users that try to attack the system. There are many types of algorithms used for the cryptocurrency blockchains to secure their transactions, but proof of work and proof of stake are the two main types that are used by many cryptocurrency companies. Still to this day, the debate between both algorithms is still very controversial. After learning about both algorithms, what do you think? Do you think proof of work is better or proof of stake? Let us know in the comments below.